Hello, welcome to the session. And today we'll be talking about the security considerations for MLOps infrastructure on AWS. Welcome to this session, and hopefully you enjoy it. Thank you. According to a research company called Hidden Layer, 77% of companies reported identity breaches to their AI system in the past year. The remaining were uncertain whether their AI models have been attacked or not. This is a staggering metrics, which it's really important that companies understand the security stance of their ML infrastructure, especially considering the fact that AI is becoming an integral part of our daily lives, both in software development and even outside of software development as well. In today's session, we'll be talking about a number of components. Our agenda for today will start with understanding the why. We'll look at a typical MLOps pipeline design and also look at the security challenges in designing ML systems. And then we'll go ahead to discuss the best practices for securing your ML infrastructure and look at some case studies for implementing MLOps on AWS. And finally, we'll have a look at the shared responsibility model. Why is this important? A couple of months ago, Air Canada lost, over $800 million in a small claims court due to the fact that a customer who's gone on the website to chat to the chatbot to get some information about the airline ended up getting, inconsistent answers as a result of the AI system or the chatbot hallucinating. And this is a serious issue. Even though this particular case isn't a life-threatening one, there are cases where we would want to give permissions to AI for them to, make decisions on life or death situations. And it's really important to design systems that are highly secure and at least minimize the cases of hallucination and other similar, concerns of AI systems as much as possible. My name is David. I currently work as a software engineer. I also am a technical instructor and an AWS community builder. In my spare time, I do contribute to open source, play the table tennis, or in some cases, I do enjoy playing video games. Let's crack on. So first of all, let's have a look at a typical design for ML ops infrastructure and what it looks like. A typical infrastructure here, the first stage we ingest the data from a data storage like Redshift, RDS, or similar data storage source. Then we pre-process this data and prepare the data to be used for model training. Then we go ahead and train the model. After the model has been trained, then we go ahead and validate the model that we have created. Based on specific benchmarks or metrics which we set, we go ahead to, do some validations and evaluation of this model. And when we are fine with what we have, we go ahead and deploy this model to production, where applications can, run inference on these machine learning models and make predictions. Beyond that, we go ahead to also implement monitoring systems to monitor the health of our system and also to ensure that, a model doesn't degrade, or in cases where the model degrades, it's retrained based on the new data we have, or you know data which we specify as well. And then so goes on the cycle as well. It's really important for us to understand that for this system to thrive, we need to be able to secure each of these components, each individual component, and provide the highest level of security while ensuring the system is able to handle, you know, different use cases, and companies are able to adapt this architecture to their specific use case. However, it's really important for us to design systems that are highly secure and able to withstand the test of time. For us to be able to design secure systems, we essentially need to be able to understand what specific security concerns are out there, and what security concerns do we have to have at the back of our mind when building out an MLOps infrastructure. So some of these concerns are what we'll be looking at in the next couple of slides, so we can understand the problem a lot better. On the data security layer, different companies churn out terabytes, gigabytes, and petabytes of data on a regular basis. And the management of the end-to-end um, the end-to-end pipeline of this data, from the time it's ingested to the time when it's used to train the model, has to be done in a highly secure manner, because some of these data also contain personal identifiable information, which will be critically devastating for the business in a case of things like data breach, or data poisoning, or the case may be. So it's really important that these data security concerns are addressed as well. And what are some of these concerns, as you may ask? Cases like access logs, data poisoning, unencrypted data, and lack of data versioning. These are concerns which need to be addressed from the onset when designing ML systems. For data versioning, this is really important for us to understand and keep track of what version of our data we used to train our machine learning models, and not just for the data, other components like hyperparameters which we used, the variables which we used, the hyperparameters and parameters which we used to train our model. We need to be able to keep track of all of these, and the changes that are made to them as time goes on. So this way, we're able to go back and reevaluate our changes and use them accordingly to achieve our set objectives. Next, we talk about model security. Our model being an intellectual property, is really critical for us to understand, to secure our models, and also the model integrity is really critical, as it is very important that the integrity is maintained to be able to serve our business as needed. Some of the security concerns with regards to model security is one of supply chain vulnerability and model theft, and several other security concerns as well. And you may be wondering, what exactly is supply chain vulnerability? When building our software systems, in a number of cases, we use software systems that are provided and built by communities. These softwares allow us to accelerate the rate at which we deliver software to our clients as well. Supply chain vulnerability refers to the security challenges or vulnerabilities that get shipped alongside some of these softwares which we do not necessarily have control over. So some bad actors may take advantage of some of these softwares, some of these third-party softwares, implant in them or embed in them, you know, um, embedding them malicious code that would compromise the security of our system. It's really important to understand the supply chain vulnerability so we will be able to guard against them when building out our ML system. Next, we have the model theft. A model is the end product of our machine learning training pipeline, and it's critical that this model is kept securely to prevent it from being taken over. Next, we talk about the pipeline security. Pipeline security prevents looks at preventing unauthorized access and malicious code in our ML pipeline. For pipeline security, some of the vulnerability concerns include the vulnerability management, lack of monitoring and alarms, and inadequate delivery lifecycle. For inadequate delivery lifecycle, we're looking at cases where the entire process of delivering our ML pipeline is not done to the standard as it should be. Ideally, MLOps involves building out solutions that uses similar implementations for the software development, traditional software development, and applies those same principles and guidelines for data science teams to deliver production-ready machine learning pipelines. So it is really critical that the delivery lifecycle for delivering these production-ready pipelines are done to a high standard. The last but not the least is the deployment and serving security. So this refers to the safeguarding of the endpoints and API interfaces for which we use to deploy our models to production. So some of the security concerns including output manipulation, DDoS attacks, and data leaks from the model as well. Having looked at some of the security concerns for each of the components that is involved in building out the machine learning infrastructure, let's go ahead and look at some of the best practices that can be implemented to, help us, build out secure systems. For the data security mitigation, we can implement data access restrictions and temporary credentials that allow us or the users of our platform to be able to have access to the data they need and only the data that they need. And in addition to that, we also have these systems or these users able to assume temporary credentials to perform any operations which they intend to perform within the cloud environment. Next, we look at setting up network boundaries and controls, VPCs, which allow us to isolate our environment. This way, we are able to, perform our experimentation and do any other similar work within a controlled environment without having to pass through the internet, public internet. Next, we talk about data encryption at rest and transit. Encryption of data at rest and transit is really critical when building out ML systems. Alongside minimizing the data, the PII data, to ensure that the data set we are working with is secure at all times. Next, we talk about the implementation for the data catalog. So, data catalog here refers to the entire life cycle for our data set from the point it's ingested up until the point where the data is used to train our machine learning model. And lastly, we also have the data validation, which refers to us, being able to validate our data to ensure that, if it's fit for purpose as well. Next, we talk about model security mitigations, implementing things like scanning of our models for malicious code when using third-party libraries, audit and log trails, train models on relevant data from trusted sources, and then using hardened runtimes for our ML pipelines as well. Next, we talk about the pipeline security mitigations. With the pipeline security mitigations, we can implement event-driven automation systems that triggers our system to turns our system into self-healing solutions, which triggers for retraining of our pipelines when a specific threshold is no longer being met, or handle more complex workflows as the case may be. And also we implement adequate unit and integration tests for our pipelines. And lastly, we set up alarms and monitoring for our system. The last but not the least is the deployment security mitigation, where we deploy our infrastructure to run within controlled or isolated environments. Then we also implement rate limiting the number of inference queries that are made to our endpoints, and also reducing or eliminating DDoS attacks on our system as well. Next, let's have a look at some of the case studies for implementing secure MLOps pipeline on AWS. This first case is a simple implementation of SageMaker AI. SageMaker AI can be deployed within a VPC, which essentially is deployed within a private subnet. Within this VPC, we can effectively talk to different AWS services or communicate with different AWS services within the AWS network without having to, pass through the public internet using the VPC endpoints. So as you can see from here, we can connect to our S3 bucket, our CloudWatch logs, SageMaker API, all within our controlled environment. With the deployment of our SageMaker AI within a VPC, it provides us with SageMaker Studios. SageMaker Studio also gives us the capability to, create SageMaker pipelines and also define specific jobs like processing or batch transform jobs that's run within our environment as well. Next, we look at how we use IAM to, provide least privilege access to different components of our machine learning pipeline. We have the data scientist role that's able to assume the SageMaker execution role, and also in turn, able to assume the specific job roles like the processing job, the training job, even the SageMaker model role as well to perform specific operations which we have defined using our IAM policies. With this, we've had a good understanding of the different security concerns and also the mitigations for these security concerns which we have. Finally, let's talk about the shared responsibility model. And what is it? The shared responsibility model talks about the capabilities or the responsibilities which the customer has to protect the cloud infrastructure, and in turn also outlines the responsibilities which AWS has to secure the cloud infrastructure. Over here, we have AWS being responsible for security of the cloud and the customer being responsible for security in the cloud. That in turn means that for AWS, they're able to seamlessly manage the regions, availability zones, edge locations, the infrastructure that handles all of this, alongside the compute, storage, database, and networking layers, as well as the software that provides all of these capabilities to us, the customer. And also for customer, who is responsible for security in the cloud, we are responsible for client-side data encryption and data integrity authentication, server-side encryption, networking, operating system, firewall configuration, platform, applications, identity access management, and as well as the customer data. So this gives a clear distinction about everybody's role in ensuring a secure cloud platform. To learn more about some of the bits we've covered in today's presentation, you can read a bit more on the Hidden Layer website for the article AI Threats Landscape and Databricks AI Security Framework, which provides a bit of the bits we've covered today in a bit more detail as well. Thank you very much and have a lovely day ahead.